this video, we will demonstrate how to plot functions using VPython. So if you go to the website of VPython, you can see a link for the different functions and for the tutorials in doing vector operation, graphs, and math functions. So we choose graphs, and let's look at a sample code used to plot a function. So we need a graphics curve. So the function for the graph is gcurve if we want it to be aligned. And then we use a loop for loop function using the range. So if we write for x in range 0 to 8, so the first value here is the minimum value, and then the second number is the maximum value, and the third number is the step size or the increments. Gcurve to create a graph, and then to plot the function, use a for loop. So in Trinket, you open a Trinket file, and then to plot or to create a graph, use gcurve. And then to plot the function, use the for loop for x in a range. And the first number is the minimum value of the interval. The second number is the maximum value. Let's say 1. And then the third value is the increment or step size. So let's say 0.01, or we can have it 0.1. So for the plot, what we want is to plot this. So you can have a variable to represent gcurve, which is the graphics curve. Let's say name of graph is equal to gcurve. So call that variable name of graph. So you can use any variable name dot plot, and then inside you will have the function. So let's say you want to plot x and x plus 1. So this is a linear plot. So click run, and then you have a linear graph here. So you can also use graphics scatter plot, gdots, and then you can add attributes to the graph itself. So for example, in creating the graph, you can use a template so that we can change the labels for the horizontal and vertical axis. So let's define the graph template using the function graph. And then you can input all the attributes of the graph template inside this function. So for example, you want to include the title of the horizontal axis. Let's say that's X. And then the vertical axis is f of X. And then you can also add the title of the plot. Let's say X versus f of X plot. You can also change the size or change the height of the plot. Let's say 250, make it smaller, and width is 300. Okay. And for G dots or G curve, you can add color attribute. Then also the label. Let's say this is F1X. So the label is the legend that you see here. So put this back to G curve, and then we define the functions. So here we don't include the function itself, but we put it as an operation in the for loop. So let's say if you plot x squared, and then we make the interval from -1 to 1. So we can see the parabola. Or we can have square root of 1. So that's 1. X raised to 1/2. You can see this plot. So you can extend this to, let's say, -1 to 2. Of course, the square root function has no value for negative numbers or negative integers. So another way of representing this function is to define the function itself. So let's define the function. So instead of writing it here, we can just call the function f of x. So let's say define f of x. So this function takes x as the input, and then it will give you the value for f of x. So let's say we want y equals x raised to 1/2. So instead of putting the explicit function here, we just call the function f of x. Okay. And then return the value of that function in line 7. Return y. Okay, let's run this. So now you have the function given by this plot. So this is, let's say this is F1. Then you again define another function. Let's say we can define another function, y equals Instead of exponent, you can use square root function. Square root of x, you should get the same plot. Okay. What else? So if you go back to the graph link, we have built-in math functions that we can plot: absolute value, sine, cosine, tangent, arcsine, arccosine, arctangent, and so on, exponential. And then you can also have random numbers. So let's try those built-in functions. So if we choose try the absolute value of x, we make it symmetric. So the absolute value function gives you the positive value of that number, or the magnitude of the number. So we have these two symmetric curves. What else? We can use, or you can plot sine function, sine x. So take note that uh, Visual Python uses regions for the trigonometric functions. So if you change the range from negative pi to pi, you get this sine function. But if you use degrees, if the input value for x is in degrees, you use the regions function. So meaning if you input a number in degrees, it will convert it to radians and then take the sine of that number. So for example, we start at 0 and then pi is 180. Oh, this should be uh, from negative pi to pi. So from 180 to negative 180 to 180. Okay. So if you make this cosine and the input is in degrees, so you still use radians. Okay. So if you remove the radians function, it will accommodate numbers in radians. So you change this to radians, pi to pi. You can also have tangent x. Okay, so as you can see, um, in the interval pi over 2, negative pi over 2, I mean, and positive pi over 2, it does not go up to infinity. But if you change the time step or the step size, you make it smaller, and you can see that you have larger y values at negative pi over 2 and positive pi over 2. Okay. What else? Exponential. So y is equal to exponential negative x. Maybe we change the, go back to 0.01 step size. So this is the exponential, negative exponential function. If we make this positive, we have the exponential increase. So if it is exponential x squared, and if it is negative exponential square, we have this Gaussian function. Now, if we make x minus a number, let's say 0.5, so the center of the curve shifts to 0.5. If this is positive, then it will shift to the left. 0.5 distance from x equals 0. You can also use a random variable. So let's say y is equal to random. So running this, it will give you a random number between 0 and 1. Now, if we want to have a variable, random variable, which can have or which can take only two values, let's say 0 and 1, we can use the round function. So what the round function do is to round the random number to the nearest integer. So if we change the curve to dots so that we can see the actual values, we only have two values, two possible values, 0 and 1. So if we want to have a random variable which will take binary values instead of 0 and 1, we can have negative 1 and 1. What we can do is to multiply this by 2. So by multiplying this by 2, we have 0 and 2 as values. And if we subtract this to 1, so take note that the second term will have two values, 2 and 0. So if the value is 2, 1 minus 2 is negative 1. If the second term is 0, 1 minus 0 is positive 1. So that means the possible values will be negative 1 and positive 1. So maybe we can adjust the step size to 0.1 so that you can see the values, the fluctuation of values from negative 1 to positive 1. So which can be used to generate random walk phenomena. So you can put this back to G curve. So you can see that the dots are now connected and the fluctuation is from these two possible values. Okay. So if we want to plot two values, let's say a cosine and a sine. So y is equal to cosine x, and then y is equal to sine x. Let's say this is y1, this is y2. So we return y1 and y2. Or maybe we redefine na lang another variable for cosine. Let's define f2x y equals sine x. So we remove the function here. So this becomes f1, then return y2, return y1. So in plotting this, we just call f1 and then for sine x, we use another plot. So we label this as f2x, and then we change the color attribute to green. So we change the function name x versus f1. And for the second one, we have x versus f2. So now we change the graph to be x versus f1, and then another plot x versus f2 dot plot x comma f2. So now we have two overlapping plots, one in f1 and one in f2. So we need to define y2 here, not y. So now we have f1 to be cosine x, I mean, yeah, so cosine x, and then f2 is sine x. You can explicitly write the function here. So f1 is cosine x, and then f2 is sine x. So we can use any built-in function to be plotted in this graph. We can also use this built-in function to make other functions like cosecant. So cosecant or a secant is 1 over cosine, and then cosecant is 1 over sine, and then you just change the name or the label for f1 to be secant x, and or f2 to be cosecant x. So we have these two functions. One is secant and the other one is cosecant. So we change the interval from 0 to, let's say, 3 pi. So here we can see the cosecant and secant functions. Again, you can increase or decrease the step size to see larger values in y at values pi over 2 or increments of pi over 2 and pi over 2.